Hello, and this time we're talking about simplifying ratios. And if you've ever done simplifying fractions, like if you've got 5 over 10, and you've simplified this, say, oh, well, the top number and the bottom number, 5 goes into both of them. So 5 divided by 5 is 1, 10 divided by 5 is 2, simplifying fractions. Then simplifying ratios is exactly the same thing. You're simply looking for a number that goes into both the first and second number, or indeed all the numbers if you've got more than one, and you just divide them all by that. So 3 and 15, 3 goes into this and into this, so divide, and we have the ratio in a simpler form, and because there's no number other than 1 that goes into both the first and the second number, that is in its simplest form. Always check that, because you never know, you might sort of go, oh yes, divide by that number, and there might be another factor that you know, maybe it divides by 6 and you saw it divided by 3, so you need to divide it by 2 to finish it off. So always just check, does it divide in more? No, we're good. Now this next example has a sneaky little decimal in there. When we're simplifying ratios, we don't generally like to have decimals in our ratios. There's not really much point. If you're going to have decimals, well, then you may as well just work out, if this was a 1, then what's the other number as a decimal, which we do that. I'll come on to 1 to n and n to 1 ratios in a moment. But if we want to simplified and given as a normal ratio, then we should really have whole numbers, in which case we need to make this not have a decimal. So let's have that as 25 and 40, timesing both of them by 10. We're allowed to do that because it's how much one person has compared to the other. And if you give the first person 10 times as much stuff, you can give the other person 10 times as much stuff, and it's still balanced. They still have the same proportions out of the total. Total's gone up, and each person's got proportionally more stuff. So the ratio is fine, just like scaling up a fraction would. And now we've done that, we can then just cancel it like we would. Both of them have a 5 that goes in, so the 25 becomes 5, the 40 becomes 8, and we can't cancel that any further. If there's more than 2 numbers, this is a 3-numbered ratio, absolutely fine. We just need numbers that go into all 3. But we've got this decimal, so let's get rid of that first. Now we could just double things, that would work. Or you could do the times by 10, whatever. Whatever is going to get rid of that decimal and whatever you feel comfortable doing. I'm going to double it, so we're going to say 4. We're going to say 6 for that. And we're going to say 4.5 goes to 9. Now actually, when we look at this, there's nothing that goes into all of these. Obviously 2 goes into these, I just doubled them, but not into this one because it came from a decimal. And although 3 goes into both of these, it doesn't go into this. In order to cancel it down, there'd have to be a number that goes into all of them. Let's do the same thing again, but this time let's times it up by 10. So we get 20, 30, and 45. This time we can say, oh yes, look, 5 goes into it. 5 goes into all 3 numbers. 5 goes in 4 times, 5 goes in 6 times, 5 goes in 9 times. We get the same answer, so it doesn't matter what you do as long as you apply the rule to all of the numbers. You scale them all up by the same amount and you divide them all by the same amount if you can. And the last example here has a unit. Now, we shouldn't have units in ratios. Ratios show a relationship between 2 numbers. It says, if I have this amount, you have that amount. But it's not a strict amount. It's like for every 1 sweet that I get, you, greedy, have 5. Okay? But if I eat 7 sweets, then you would eat 35 sweets, because the relationship between 1 and 5, you got 5 times as many as I did, is the same. If I have 7, then you have 5 times as many as I did, you have 35. It's the relationship between the numbers that's important, not the absolutes. And we can't really have a relationship if it's in different units. So a good ratio should have no units, and we do that by making the units the same. So we're going to say this is 2.2 to 1.1, and now they're both in kilograms. That was already in kilograms, and 1,000 grams in a kilogram makes that 1.1. And you might say, oh, right, okay, well, let's simplify this now, and we can times it by 10 and get 22 to 11, and they both divide by 11, and it's, oops, I didn't mean to put those there, and it's a 2 to 1 ratio. Now, you might have been able to see that you could, it was just, this is double that one from there, but it's up to you how you do that, and how you pick out what numbers will divide and what won't. But hopefully the key thing is that if you've got units, you've got to get rid of the units by making the units the same, and then you can ignore them. Now, I did say you can also write ratios in 1 to n or n to 1. So having simplified it to a nice relationship, this makes sense in the terms of, if I'm counting things out or sharing things, 1 for me, 5 for you situation, or 5 for me, 8 for you, or something like that. When you're counting out, easy to sort of group it and see that relationship. But if I want to compare these ratios, it's hard to see which one is better than the other. Now, actually, these ones aren't too bad because they're all quite distinct. This is 5 times bigger than this. This is somewhere between 1 and 2 times bigger, and obviously this is twice as big as that one. So it's quite easy to see which one's bigger and which one's smaller. But it's quite plausible that you might have ratios where it's much harder to see which one's bigger and which one's smaller. Let's say 23 to 194, or 25 to 203. Which is bigger and which is smaller. Now, you might be able to sort of logically say, oh, well, actually, because that goes in that many times, but you might be able to logic it. But it's much easier if you're trying to compare two ratios like this to take one side down to the number 1, and then you can just look at the other two in decimal form. And we can do that quite easily by simply dividing both sides by the same number. So, dividing both sides, yes, by the same number, and specifically the number you want to make 1. So to make this a 1 to n ratio, how do you turn 23 into 1? You divide by 23. So what's 194 divided by 23? It is, unhelpful, yes, let's press ST, 8.435 to round it. And then for the second one, we'll do the same thing, divide both sides by 25, that makes that a 1, and 203 divided by 25 is 8.12. So you can see that this ratio is, well, it depends. Is it better or is it worse? It depends who you are. If you're this person, then this ratio is better because you're getting more stuff than you would in this situation. If you're this person, I suppose it's not as good because in this situation, if you're sharing stuff out, you're going to get less of the share compared to if you were in this one. And of course, if you want it in an n to 1 ratio, if you wanted to compare, make the second values equal and compare the first values, you're just going to divide by the second number. And again, it depends which side you are and which one you want to be bigger or smaller as to whether being a bigger number is better or smaller. Now, you can cheat slightly. You can simplify ratios down like fractions. Because it's the same maths, you can get your calculator to do it, just be careful. So 3 to 15 as a ratio is definitely not the same as 3 over 15. Definitely not, because a fraction is how much out of a total. So this guy has 3 out of 18, and this side has 15 out of 18. So this fraction 3 over 15 has nothing to do with this ratio, but it will cancel down in the same way that the ratio will. So the answer is 1 over 5. So this will simplify as 1 to 5. So you can cheat and use your calculator to simplify the fraction, as long as you remember that don't write it as a fraction. It's just piggybacking the numbers. It doesn't translate into a fraction in that way. Yeah, you have to do it out of the total to be a fraction, so just be careful. It'll do the same thing with decimals. So you can pop that in, and the calculator doesn't like decimals. It gives you as a nice fraction. So 5 to 8, so that's all very well and good. But be careful, because a three-pronged ratio, it's not going to do that, because you can't write in a three-part fraction. That doesn't kind of make sense in the same way as this. So you can't do it for this. You have to do it manually for that one. And for this one, again, the bit that's actually difficult is, and remembering to do it, is changing the unit. And again, it won't do that on this. So you need to type it in. You can do it as a fraction, you can type it in, but you have to do the conversion of unit first. And of course, if it gives you a whole number, and you're like, oh, well, where's my fraction? What's my ratio? It means that the second number is a 1, okay, which we had earlier. Because obviously in a fraction, 2 you don't write as a fraction, but it would be as a fraction 2 over 1. So our numbers are 2 and 1. So just be careful if you get a whole number. If you are checking things on the calculator, you can do that, but just be careful, because you're getting it to do something else that happens to use the same numbers. It's not actually an equivalent thing that you're asking it to do. You are doing something different. Okay, so just be careful. Any questions and comments, as usual, pop those down below. Otherwise, cheerio.